Hi everyone, my name is Mateo Lopez, student of the Salesian Politécnica University, and in this case I make a project where we simulate and execute different configurations of a typical neural network, making use of libraries in Python, among which are SymPy, Keras, and TensorFlow, and others. In order to obtain the smallest possible error given data corpus of the order of hundreds of thousands samples, these samples contain as result a specific movement, but the cause of these movements are the data that will serve to train our neural network. As a first step, is the importation of the libraries necessary for the development of the project. As you can see here, we import Pandas, Numpy, Sklearn tools, Keras, another Sklearn tools, and Matplotlib to grab our results. The first method is responsible to generate the graph that shows the error of the two best results that we obtained during the training and validation phases. As we can see here, we use the Matplotlib tool, and we graph the learning curve. As we are going to talk about this the finish of this project. Now we proceed to load the corpus that contains all the necessary information to train the neural network. So the columns that make up this corpus are the name of sequence, the movement label, the timestamp, the datetime, the x coordinate, the y coordinate, and the z coordinate. And the result is the activity carried out. Now now we have to consider the body parts involvement in each movement. So these movements are represented by a code. This cannot be interpreted by the library. So we have to convert this to a numerical value, and the possible values are the next ones. These four are the possible results. So we transform this code to this number, this code to this number, this code to this number, and this code to this number. Now, in the same way, we have to change the codes of the results to a specific number. Walking, we replace walking to number 1, falling, lying down, lying, sitting, down, sitting, standing up from lying, on all fours, and sitting down on the ground, standing up from sitting, standing up from sitting off the ground. We have 11 types of results that we change to value numbers with this line. As we can see, we replace this for this, and the same thing with the other cases. The timestamp column is considered as unnecessary in this case, so we have to convert. So we have to delete or drop this data on the corpus with this line. The timestamp, we have the date in other data, so we don't need the timestamp because it's the same thing. So the first column is an identification of each data, so we have to drop this column too. Now, from the date and time column of each data taken, only the hours work taken since is the test. It was considered the only we considered only the hour contributed to with necessary information for the system. So we once the time have been obtained, the column is changed according to the data obtained. We change the data. We code the data with these lines, and when this for finish, we change the corpus column with the data obtained. Now, for this project, we use hot encoding because it's considered that allows better results. Then we use libraries like Keras and TensorFlow to convert the output to an succession of zeros and ones numbers properties of the hot encoding. This line make it make that well, we just print the results with this line, but after we implement this in the MLP classifier. Now the entries will be equal to the all of filtered information of the corpus with the exception of the result. So we take all the columns of the corpus, but I drop the results column. Now we have to separate 80% of the data for training and 20% the data for tests to train the neural network. With this line, we specify here the percent and the entries that we have to separate. Now we proceed to scale the data before proceeding. We scale with these lines. We scale the trained entrance and the test entrance. Now we create a neural network with MLP classifier. It is a function that consider the following parameters: the activation function, as we can see here, and the solver for query optimization that we can see here. And we define the maximum iterations that we consider that is important to make to the system, to the training of the neural network, and the tolerance and the number of hidden layers that we have in our neural network. We have 2 hidden layers with 30 neurons each one. And now we need to make a copy of MLP to later make a learning graph. We use this to classify in these lines and this to grab the learning graph. Now we have to train. We make the training process. We use MLP fit that receives the train entrance and the out train data. We make a prediction with MLP fit predict that take the test that we separate in these lines, and we make a confusion matrix that give us the results that makes how I can say that correctly classified and the non-correct classified that we can see here. We have all the results. Now to finish the project, we have to proceed generating the classification report to better visualization of the results obtained. In this case, we have here the percent of result that matches with the coded output, and in this case we have to
execute the method that I talked to you about in the first part of this video, and we obtain these lines in this graph. We can see, as we can see here, we can visualize the changing learning process. Now, for the project, we have to consider the two best ways to train this neuronal network, changing some parameters. So best the best choice that I make is just take not just the hours, not just the hours. So I take the seconds that that I for each data. We have to multiply the hours to the 3,600 seconds, the minutes for to 60 seconds, and the seconds. We just plus each one, and we have the seconds that we have for each data. Sorry. Now we just put this data to the corpus, changing by the hour that we have in the when we charge all the data. And to finish this session, I can show you how the results change. Not change a lot, but is another way to process the results. Let me see. We have a lot of results here. We have this confusion matrix and the result that we obtained. As you can see, is the same result that we obtained here, but is another way to process the data and take care about the parameters that we have. So we have 72% of matches, of correct matches. The same way we graph the learning curve. So that's all. My name is Mateo Lopez, as I mentioned it in the start of this video. So thanks for watching.